Hey guys, good morning or evening whenever this has been posted and you're seeing this. Like I said yesterday, we had some technical difficulties in the stream, so I'm just following up with a video to make sure that we get through all those guided practice problems and hopefully you kind of clarify some of those questions that you may have over the assignment that you should be working on today and kind of between now and Monday and trying to get that finished before our quiz. So we'll talk about the quiz at the end. I want to jump straight into over here and get straight back into the problems that we were talking about yesterday. So yesterday we left off with number 5. Okay, so that's kind of where I want to pick up. This is guided practice number 5, by the way. So this is on page 355 in your book on those pages that I linked on the Google Classroom post. So on number 5, we had the polynomial equation x cubed plus 7x squared, subtract 9x, subtract 63. So the reason this one was unique is because you look at this one and not all of those have a variable with it. So in the beginning problems, all we were doing is we were pulling out the common variables and then we started to factor from there. But on this one, like we said, we have to take a different approach. So on this one, we look at this in 2 parts. So we look at the first part, which is the x cubed plus 7x squared. Then we look at the second part, which is the negative 9x subtract 63. And what we want to do is we want to factor those out individually. So 2 separate kind of parts to this one, and then we'll bring them together later. So with the x cubed plus 7x squared, obviously, like we said yesterday, they both have an x squared in common. They both have 2 x's in it. All right. Then when you pull out an x squared from an x cubed, leaves you with just an x. When you take an x squared away from a 7x squared, it leaves you with just 7. So then we factor out an x squared, and we're left with an x plus 7, and that's in the first part. Then in the second part, we can factor out a negative 9 because negative 9 will divide into both negative 9 and negative 63. And then when we take the negative 9 away from the negative 9x, we're left with just x. And then when we divide negative 9 into negative 63, it leaves us with positive 7. So when you do it in 2 parts like this, what you should see is what's left in those parentheses. If it's the same thing, then you can factor it. If it's not the same thing, then you're not going to be able to take it any further. But you see that it's x plus 7 and x plus 7 here, so we can pull that out. So what we do is we pull down that x plus 7. Because it goes with both, so that means we can bring it down. Then what we have to do is look up here and say, okay, what's left that was factored out? So then we have this x squared right here, and we have this negative 9 here. So those 2 create our other factor or other binomial that we're going to use. So then we bring that down here, x squared subtract 9. Okay, if we couldn't factor either one of those, we would be finished. But since it's an x squared subtract 9, again, that's our difference of squares. That's the one that we look at. There's no middle term, so it has to be plus or minus the same number. So to finish it out, we know it's x plus 7. We bring that down, but then x squared minus 9 is just going to be x plus 3 multiplied by x subtract 3. Then this is what we're looking for right here. That completely factored version of the original equation up there. Okay, and that's kind of the goal right now. And then we're going to finish up this video talking about how to solve. All right. Then the one right beside of that one is number 6 there, and it's a little bit different, but along the same lines. So we have 16g to the 4th subtract 625. All right. So on this one, we have to think about when you have 2 terms, and again, this is difference of squares where you're looking at what can you square to get the first term, what can you square to get the second term. Okay. Well, if you're looking at the first term, it's 16g to the fourth. So in order to square something to get 16, I hope we all recognize that that's 4. Right? 4 times 4 is 16. Then you think about, okay, what do we square to get g to the fourth? Well, product of powers property says when you multiply things, you add the exponents. So if you do g to the second multiplied by g to the second, then that gives you g to the fourth. So that would be the first thing that we have to look at is how do we take these first two terms that I wrote out there and get to that 16g to the fourth. And we get that by 4g squared multiplied by 4g squared. Then we see that we have negative 625. But what you notice again is that there's no middle term in there. So what that means is that we're going to have to find a square. So 5 times 5, 6 times 6, 7 times 7. The same number multiplied by the same number. Well, on negative 625, we could just take the square root of 625 and see what that is, but I'm just going to kind of go ahead and do that. And in order to get 625, we do 25 multiplied by 25. All right, then the last part of this is to know those signs. Well, in order to get a negative 625, one has to be positive, one has to be negative. So I'm going to put addition here, subtraction there, and then that's also why there is no middle term. So now, in order to factor this, there's one of these you can break down and one of these you can't. So if you look at the first parentheses right here, and let's think about if we were to solve that. We would subtract 25, but then that would be negative 25. Then we'd be eventually taking the square root of a negative number, which would be imaginary. So we really can't break that down. We can't factor that because it's not a real solution. You're going to get imaginary solutions for that first one. So for now, we're just going to bring that one down. So 4g squared plus 25. We're just going to bring it down. And you'll notice that's going to be the same anytime it's addition in a binomial like that, because you're always going to have to subtract it over, and then it's going to leave you with imaginary solutions. So we're not going to factor that any further. Okay? If we look at our second parentheses here, we can factor that because, again, that's a difference of squares where you have 4g squared. So, okay, what can multiply together to give you 4g to the second power? Well, it has to be 2 times 2, and then each of those have 1g, because 2g multiplied by 2g is going to give you 4g squared. And then what multiplies to get negative 25? Well, it has to be 5 times 5, and since it's negative, you have 1 positive and 1 negative. Okay? And that would be, again, your final answer at this point, because all we're trying to do right now is factor. So that would be guided practice number 6, factored. So now the last part of this target says that we want to factor polynomials first, which is what we're doing in these two examples, and then we want to actually solve these polynomial equations through factoring. So that's kind of the last part that we're going to do here through the guided practice problems, like numbers like 8 through 10. But let's look at just one like number 8 first, I guess. So let's look at 8. So let's go ahead and get us a new screen here. All right, so if we look at guided practice number 8, at the bottom of page 355, we have 4x to the 5th, subtract 40x to the 3rd, plus 36x, and that's equal to 0. All right, so we just have to, at the very beginning, okay, if we're thinking about, because what the question is asking, it's wanting us to solve, meaning we want answers. I want solutions for x. What are the values of x that you can plug into this equation that's going to give you an output of 0? Okay, that's my whole focus here. Well, in order to find that, we can just factor and break it down as far as we can. Then we can get those solutions easily once it's fully factored. So the first thing is we want to try to factor it as far as we can. So hopefully you already noticed that if we look at all three of these terms, they all three have an x. So first thing I'm going to do is factor out an x. I take 1x away from 4x to the fifth. I'm left with 4x to the fourth. I take 1x away from the second term. I'm left with negative 40x squared. Then I take an x away from the third term. I'm left with just 36. Okay, so that would be step one. All right, you could have also in step one noticed that you have a 4, a 40, and a 36. Well, all of those are divisible by 4. Okay, so I'm going to go ahead and factor out a 4, and that's going to be out here with the x. Now, you could do this in one step. I just kind of wanted to take it step by step in this example to show you kind of what I'm doing each time. You can definitely factor out the common factor and the common variable in one step. I would actually suggest to do that, but just for the purposes of showing you a full problem, I'm kind of taking it step by step. So when I factor out a 4 from the first term, leaves me with x to the fourth, because 4 divided by 4 is 1. When I factor out a 4 from the second term, negative 40 divided by 4 leaves me with negative 10. And then again, when I factor out a 4 at the end here, leaves me with 9. So now I start to simplify it up a little bit, okay? So now I have to look at what's in the parentheses and think about how can I factor that. Well, this is very, very similar to when we factored quadratics, except this time it's not a quadratic. It's a fourth degree polynomial. Well, it's going to be the same thought process. Well, how do I get x to the fourth? Well, I have to do x squared multiplied by x squared. If it was x squared in the original one in parentheses, we would do x times x. Well, same thought process here. Then we are still going to work on the ideal of multiply. So, I erased. Multiply to give me negative 9. Okay. So multiply to give me negative 9, or positive 9. Then add to give me negative 10. So the whole multiply add concept still applies here. So if we think about that, multiplying to get positive 9, but adding to get negative 10. Well, the only way that we can add to get negatives, but multiply to get positives, is if the two factors that we're using to multiply are negative. So we know that our two factors are going to be, let me do this in red so we stay, our two factors are going to be negative 9 and negative 1. So if I do negative 9 multiplied by negative 1, okay, then I get positive 9. If I add negative 9 to negative 1, I get negative 10x squared. So that's kind of what we're looking at here. Then we have two problems that we can hopefully really quickly just multiply out, because x squared minus 9 is going to be x plus 3 multiplied by x subtract 3. Then x squared minus 1 is going to be x plus 1 times x minus 1. Okay? Then all this is equal to 0. So right here, this line, this is fully factored. And that's what we want to be able to do. That's the first half of the target. Now, the second half of the target says we want to solve it. We want to find what are going to be those actual numbers that you can plug in. So what you see from the fully factored version of this equation is that it's kind of broken down into 5 parts. Okay, we have the 4x that we factored out. Then we have 4 different binomial expressions in parentheses. Each one of those is going to represent one solution. So if I want to find out what those solutions are, all I do is take each one of these parts, and we will do this in a different color. So we take this 4x, and this is finding the actual solutions, and we just say, okay, when is 4x equal to 0? If you divide both sides by 4, obviously, that's when x is 0. That is one of your solutions. Then we go to our next piece, which is x plus 3, and we're going to say, okay, when does x plus 3 equal 0? Subtract 3 from both sides. It equals 0 when x is negative 3. That's another one of our solutions. And then we just repeat that process for each individual part of our fully factored polynomial. So if I was to say x minus 3 equals 0, we'd add 3 to both sides, we get positive 3. Then x plus 1 equals 0, subtract 1 from both sides, x equals negative 1. And same thing here, x is going to equal positive 1. So we actually have 5 roots. That's another term you'll see, or simply just 5 solutions. Those are the 5 values that if we go back to our original polynomial equation up here, those are the 5 numbers that when you substitute those back into the original equation up there, they're going to equal the value of 0. Okay, and that's the thing with polynomial equations. When you're getting ones that's to the 3rd, 4th, 5th degree, you have multiple roots. You have multiple options that can be substituted in there to give you that value that you're looking for, which is 0. Okay, so basically that kind of wraps up the guided practice problems. So if you're finding that you get to the problems that I posted and you still have some that are a little bit rough or a little bit different, or you see one that you're just a little bit unsure of, shoot me an email. Okay, comment on the assignment on Google Classroom, and I'll be more than happy to try to explain it. And then, or I can just post. It's just super easy for me to come on here, work something out on my iPad, record it, and send you like a screen capture of that. So I can definitely send that out if you have any questions over specific ones. But take kind of today and tomorrow to try to work through that assignment. Then before Monday, shoot me an email. Let me know kind of what you're having problems with, because on Monday we are going to have a quiz. That quiz is going to be on Google Forms, posted on Google Classroom, and it will be timed, so it will have to be within a specific time window, or I can open it up to you at another time as well. But it's not just going to be posted and you have 10 days to do it. You're going to have a 2 or 3 hour window that you're going to have to get that done in, but I will definitely clarify that for you more towards the end of today, or maybe even over the weekend. I'll kind of post something that clarifies that a little more. So if you have questions, email me. Hopefully that kind of clarified all the guiding practice problems. You can get into the actual assignment and try to get those done and get those worked out. Let me know if you have any